What are the four most popular lens barrels? 19, 26, 36, and 50. I'd like to take this piece of paper. What is this angle here? 90. Let's fold this piece of paper over and make a triangle. Try to get this corner as sharp as you can. What is this angle now? It's 45 degrees. I'd like you to take this piece of paper and hold it up without poking yourself in the eye, like this underneath your eye. And take a look around, and you'll see that the white expanse that's underneath this paper, or that's underneath your eye, that's what a 50-degree lighting unit is going to light up. Let me see if I can get this to work if I hold it here. So from your angle, I'm at the edge of the light. And if I go all the way over here, I'm at the edge of the light. So if I'm anywhere in this white field, I'm going to be lit up. Okay? The next light, let's take our piece of paper and fold it in half again. What's this angle? 22.5. So if we do the same thing, we hold this up. We now see a little bit smaller than a 26 degree and a little bit larger than a 19 degree. So that's what that's going to cover. Well, what about a 36? Take your piece of paper. Let's fold it in half again. 11.25. So each one of these folds is now 11.25. Open it up all the way, and we have the 45 degrees, which is our 50-degree unit. So let's fold one in. So now we have 11.25, 22.5, 33.75. So this is basically your 36 degree. Folding it up like this, we've got our 36 degree. Now if we combine these, we can make a combination of different lights together. So I have my 45, got my 33.75, I've got my 22.5, and I have my 11.25. If we take another piece of paper and we draw a ground plan, let's do a quick stage edge right there, do a proscenium arch right there. Let's make a box boom position over here. A standard size piece of paper. This is what size? So let's fold it in half, like so. So that was 11 folded in half. We have 5.5 inches. In 1 inch scale, that's 5.5 feet. In half inch scale, that's 11 feet. So this box boom is 11 feet away from the edge of our stage. So let's work in quarter inch scale. So it'll be 22 feet away. So in quarter inch scale, this is 22 feet. 22 feet from the box boom to here. And let's see, our stage is just over 22 feet wide. Let's see, if that's 22 feet, we fold this over again, that's 11 feet in quarter inch scale. We fold it over again, that's 5.5 feet in quarter inch scale. So we've got 11, 22 feet to here, plus one of these folds, which was, what was it, 22, 5.5 feet, 5 feet, 6 inches, and this was 22 feet. So our proscenium opening is 27.5 feet, 27 feet, 6 inches, using a piece of paper without a scale ruler, and our angles are being made without protractors. So if we take our 45 degree light and we set it up on our box boom, we can see that our near shot is being covered fairly well with a 22 degree, with a 45 degree angle, so that's a 50 degree light. And to get to the other side of the stage, we'd mix a 50 and a 36 degree. But look at all that extra light that I'm getting. That extra coverage I don't need, because remember that a lot of this is going to be wasted height-wise. Okay? If we have the height going here, we're going to lose a lot over the height of the people. So we don't want that to happen. So instead of those two, I'm going to go with a 36 and a 26 with an overlap. And we get a coverage from proscenium to proscenium. Make our stage much wider. A near shot with a 36 degree, a far shot, 26 degree, another far shot, and we'll pretend this is a 19 degree. Let's take another sheet of paper, fold it in half, 5.5 inches. So in 1 inch scale, that person is 5.5 feet tall. In half inch scale, they're huge. So let's make it a little bit smaller. This is also 5.5 feet tall. Okay, so there's my person. So I have my person here, and I use my lights. I can figure out that I need a light from that angle to light up that person. Well, what if I have 2 people? I probably need 2 lights. Or I need a 26 degree for the near shot and a 19 degree for the far shot from the same location over here off stage. Well, what if I have 3 actors? And you can do the same thing from the other side. Now, here's the key for figuring out if students understand beam spread, is if they place the lights that will cover the stage, but in the wrong beam designations. Because obviously we want the wide shot for the near shot and not the far shot. So these have to be switched around. To further illustrate this, I've made this little diagram of front view elevation of 2 performers and a little pipe with some pipe ends. So here I'm going to use a 45 degree triangle. So my 50 degree light will be for here. These guys in front. So they're getting covered. And then I'm going to hit them the middle of the stage with a 36 degree with an overlap. But you'll see that if this guy moves stage right at all, it's not going to be covered. So I'm going to hit that actor with a 26 degree with that 3rd light here. So there are my 3 lights, a wide light, a middle light, and a narrow light. Let's look at intensities. So here we see that a 50 degree unit shows us 203 foot candles at 15 feet. A 36 degree unit shows us 404 foot candles at 15 feet. And a 26 degree unit shows 783 foot candles at 15 feet. A drastic difference between these 3 units. Now we're going to do some math for the inverse square law, which tells us that upon a certain distance, light falls off. Okay, to determine the center beam illumination in foot candles at any throw distance, center beam illumination in foot candles for any throw distance, divide candela by throw distance squared. The candela for this unit is 243,520. 243,520 divided by 225. And there's where I got my answer, 1082. So on my 19 degree unit paperwork, which is this one here, okay, I made myself a cheat sheet, foot candles for 19 degree. There's a 10 feet, for 20 feet, 15 feet, 30 feet, and so on. And the cheat sheet's available on my website, a copy of it. And this is what the copy looks like with all the dimensions and all these foot candles already figured out. I've made these people standing apart from each other, each 10 feet apart. This is 1/4 inch scale, and I've put some heights over here. And I have this pipe up at 20 feet. And I have my people at just over 5.5 feet tall, about 6 feet tall. I have them apart 10 feet away from each other. And I've already worked out the numbers. And I've worked out that I started with a 36 degree unit. 20 feet is 227 foot candles, according to the chart. So then I worked out the numbers, and I figured out that a 36 degree unit would be here. Okay. So here's my 36 degree unit at 20 feet is 227 foot candles. So let's put that right here, 20 feet away at the light. Here's my 26 degree unit. And I've marked down here that at 28 feet, it's 228 foot candles. So that's almost 10 feet more. So we put that here at this light. You'll see that I'm just about 28 feet right there. I have my 19 degree unit that says it worked out at 32 feet was the proper foot candles. So I've made a small note here at 32 feet. And there's 32 feet. So you'll see that the 3 people are going to have the same intensity from my pipe ends here at the end of a pipe, or from a box boom. So here's an app called Beam Calc by Eric Cornwell. And here you can play with the same information that I've shown. We can have a height, a distance, a beam angle. You can change the lighting units. All the calculations are based on 750 watt lamps on the spec sheets. We've got the elevation, degrees, throw, width, so on and so forth. And here's the foot candles. So if I play with this and I drag it over here, the foot candles go up. And if I drag it over here, the foot candles go down. And you can play with this tool and move things around to figure out your coverage. We can assign students to a basic ground plan. You know, they can draw the ground plan themselves. We can just do something really rough where we have a center line and so on. We've got the front of a stage. This can all be in 1/4 inch scale. Doesn't have to be in any scale because the diagonal, the angles of the lights don't change. They're always in scale. And you can do the measuring like I've just shown you with all those folding of the paper. We have our 3 characters, our 3 acting areas. You can put a setback here, ask them to do it. As far as drafting goes, if you have drafting templates, fantastic. If you don't, this is an index card, plain index card. For spots, Lecos, source 4s, and whatnot, you can cut yourself a little triangle like that. And this can be your template for drafting a spotlight. This can be your template for drafting a Fresnel or a par. Right? You can make it a little bit better than that, but that's can be for that. You know, you can make whatever shapes you want, and you can have this be the template. So if I'm laying out a light plot and I'm taking my angled paper and I'm placing it over here, we can take this over here to this box boom and just draw. That's what it is. And that's all it is. 19, 26, 36. You can ask them to give you channel numbers on top of it. This has some backlights, pars or Fresnels. There are a lot of days of walking around with a flashlight and a gel book and shining the light on your various objects, whether you had model pieces or Lego pieces or custom swatches or simply white paper to figure out what the colors were going to do and how they're going to mix. So what I do is I cut out pieces of swatch and I tape them to the back of an index card. And I come up with my color palettes this way. So I can shine it through the index card and I don't have any spill on my subject, whatever subject it is. I take a 3x5 index card, fold it in half, and I simply cut angle like that. And I do 3 of them, because 3 will fit on a card. There we go. And I take my gel book and I cut out my colors. Before I do anything else, I take a Sharpie, and I can also write on top of the card, take my color and tape it down. So now I have my card that I can shine my flashlight through. So this is a great project to put together your color palettes. If you have a collection of colors and you want to head to the costume shop and just shine your light through to talk to your costume designer and to check out colors, you need to use an incandescent flashlight. It cannot be an LED flashlight. It's got to be the classic old, I use my, well, there it is, USITT 50th anniversary mag light, because it's an incandescent light source. Let's talk intensities of gels and about reading these color charts. This one for this pink says the transmission value is 65%. And this one for this blue says it's 32%. In the grand scheme of things, what this means is that this one is allowing 65% of the light from the lighting unit to come through the gel. This one only 32, which means that this one is letting twice as much light through, which means that for every pink light you put from one side, if you're doing a traditional 45-45, one side warm and cool, for every light you put on the warm side, if it's only 32%, in the grand scheme of things and in theory, you need to have 2 lights for the cool side. When you're laying out your light plot, is looking at these spec sheets. So again, this 33 here, 65%. The sort of equivalent, a close match from Lee says 61%. A close match to the blue from Lee says 34%. That's 32, and this is 65. The primary blue from Roscoe says 9%. So in theory, and again, this is the grand scheme of things. In theory, if this only has 9% of transmission, only 9% of the light is coming out. If you have one light without any color in it, and you want the blue to appear to be the same intensity, you would need 11 lights, because 11 times 9% is 99%. So you have one light at full and 11 lights at full in order to even come close to balancing as far as intensity goes, according to the absorption rates on these spec sheets. So let's take a look at the websites. This here is from the Lee Filter site, and you can type in from the gel comparator the different colors. So let's put in 33, and we'll see that according to their comparison chart, for Roscoe 33, they're suggesting 035. And it brings up this page here. Here's the gel itself. I'm going to scroll down, and I'm going to tell it to save it to a list. And I can create this color list, Scott's Theory color list. And we can look at we can download the data sheet for just this color, and it gives us a nice big swatch up there. It gives us some more information, a larger thing here, and check this thing out. This was also on the page though, is that the dimming for this at 100% power, it's giving you the full color. But if you start dimming your light source, an incandescent light source, at 50%, it turns into that color, and at 30%, it turns into that color. Let's go find 80. Down here is their 79. And check this out. When you dim it down, it turns into mud. Let's take a look at Roscoe's version of this tool. So here's the one I want. Brings up the color here, and it puts it into a list that we can select, just like on the Lee site. Here we can have a data sheet. It gives us a lot of information. Here's what their export looks like. Very plain and no real information. On the other hand, and the Lee printout, see how it gives you just a little bit more information? It's not nearly as extensive as the Roscoe individual sheets, but it does give you a lot more information than the Roscoe collection sheet. Low resource electrical learning kit idea with a plain flashlight. I'm going to cut a strip of tinfoil. Okay. Tinfoil. Yep, okay. Take apart the flashlight. You got the batteries. Take out the bulb. This is going to give us a basic understanding of an electrical circuit, other than using the flashlight itself. I'm going to hold the tinfoil to the edge of the light bulb. Some people would insist that we call this a lamp. To me, if I can hold my fingers and it turns on, it's a light bulb. I'm kidding, I don't really care. Hold the tinfoil to the end, and there it is. We have a circuit. Now what's interesting is that it's going to be this bright. Okay? So we have a 1.5 volt, two 1.5 volt batteries. So it's a total of 3 volts going from through the light bulb, through the lamp. And it gets that bright. Okay? So now, I'm going to take some tape to make this a little bit easier. I put that on top of there like that. Tape that to that. And tape this to the bottom of this. Don't let these touch. I'm sorry. The other one was in series. So the circuit for the light bulb that I just done, the thing that I just done, was 2 batteries like this, plus, minus, with the tinfoil to the lamp connected to there. Okay, so this was an in-series run. All the volts, the current was flowing in one direction. What we're doing now is we're taking these 2 batteries and we're connecting them like so, obviously, as you've seen, plus and minus. And since these ends are connected, this was 1.5 volts, 1.5 volts, which equals 3 volts. This is just 1.5, but more powerful because they're connected together. So it's going to only be an output of 1.5. So let's go. What we're going to do here is connect this to the light bulb, in and out. Okay. And what we should discover, I'm going to hold it down flat, okay, and then touch the side. There we go. Okay. So that is an experiment that you can do with a standard flashlight. And when you examine the flashlight, we can look and see that this piece of copper material, metal, is acting like the tinfoil and going down through the switch, PR to 2.4 volt. And we're using, we had the two batteries were 3 volts added together. Okay, anyway, the important number there is the 2.4 volts. That's why when the two 1.5 volt batteries are in series, it's super bright because you're pushing 3 volts through a 2.4 volt lamp. But when they're in parallel, you're only pushing 1.5 volts through a 2.4 volt lamp. And since it has higher capacity, if you're sending less power through it, it won't be as bright. One last thing. Watch this. I'm going to hold it down to this side, which is the negative side. And I'll touch the edge. Okay. Now, if I hold it down the other side, to the positive side, touch the side, it still lights up. Because this kind of lamp doesn't care which direction the current is flowing. Its direct current can be either direction.